This is the continuation of 1.3 notes on other sampling methods. We're talking here about cluster sampling. So this is a way of sampling where you divide the population into groups, which we would call clusters, obtain a simple random sample of the clusters, then use all the members of the clusters obtained in number 2 as the sample. So you can see the picture on the side here for us visual learners that you have 5 clusters. So the entire population was scrambled up and then separated out into these clusters. And then you can see that a random sample, so randomly they chose cluster 1, 4, and 5. And these, each of the members, all 6 of these red guys, all 3 of these green ones, and all 5 of the purple ones would be the ones included in the sample. So let's take a look at another example. So we have a situation, it's actually referenced in your textbook on page 19, and there is a situation where a vote is being done on whether or not to expand the bike path, and there's a challenge to overcome in the sense that when the city of Tempe, Arizona sent out a survey in the utility bill, only those that were passionate about this bike trail, those that were passionate either for or against it, replied to the survey. So it really didn't give a general picture of how people felt, maybe some of those folks that were not as passionate about the bike trail addition. So there was a member of the city's staff who came up with this system using cluster sampling in order to get a more representative sample. Now, her initial idea would have taken 30 hours. So the second idea she came up with was taking a simple random sample. The first idea was the simple random sample. The second idea was to use cluster samplings. So the residential portion of the city was divided into 947 blocks of homes. Each block contained 20 homes. Explain how the planner could use cluster sampling to obtain a sample of 300. So we know that the sample size that we desire is 300 homes. We're going to use this step-by-step process. Here's the step-by-step for cluster sampling. So first of all, you can see that from this scenario, she divided the homes all of the residential homes in the city into 947 blocks or clusters. Right? Check. She did step 1. Step 2 is, since each block or cluster contained 20 homes, and she needed a sample of 300 homes, so she needed 300 homes total. She required 15 blocks, which would just be the 300 divided by the 20 homes on each block. So she required 15 blocks. So that would be like, in this picture up here, if there were 947 of these groups, and each one had 20 in them, and then we could poll 15 of them. So she would, at that point, in order to acquire this number 15 here, she could actually just do a simple random sample. Say she could number those blocks like they numbered these clusters here, 1 through 947, using a random number generator until she got 15 random numbers, and then she could actually go with herself and a couple other employees and just sample those random blocks and survey and see what their thoughts are on the bike path. So then for number 3, use all the members of the clusters obtained in number 2. So here we have the sample consisted of those 300 homes obtained in number 2. So this is an example of cluster sampling. Stratified sampling has some similarities to cluster sampling and some differences. So stratified sampling is when we have the population divided into subgroups called strata, or if you watch the Skittle intro video, she called them strata. Then sampling is done from each stratum. That is the singular, for strata is the plural. So stratified sampling with proportional allocation. So again, we have quite a few new terms, and you saw that that was the goal of this whole chapter, is just familiarizing ourselves with new vocabulary for the foundation of our study of probability and statistics. Step 1, again, there's another step-by-step process. Divide the population into subgroups. From each stratum, obtain a SRS, simple random sample, of size proportional to the size of the strata. Use all the members in step 2 as your sample. Okay, we're going to take a look at an example here. New Miami has a population size of 2,000. There are 4 neighborhoods with sizes of 400, 600, 800, and 200. Use stratified sampling with proportional allocation to determine a sample of size 10. Okay, so our sample size is 10. Our population is 2,000. And what we want to do here, we've already divided the population into these 4 subgroups. So that is step 1. Step 2, from each stratum, obtain a SRS of proportional size to the size of the strata. So to do that, we make a proportion. We say, okay, 400 out of the 2,000, we're going to call that neighborhood A. So a proportion, we take that ratio there, 400 to 2,000, and multiply it by the sample size. So 400 divided by 2,000 times 10 gives us 2. So we would sample 2 residents from neighborhood A. Neighborhood B, 600 of the 2,000. So we have then from neighborhood B, we would sample or survey 3 people. Similarly, neighborhood C is 800. So 800 out of the total population of 2,000 times 10 would give us 4 members to sample. And then finally, that smallest neighborhood there is 200 out of the 2,000 times 10 gives us 1 person to sample. So this should show a reasonable way to do a sample based on the fact that some neighborhoods are smaller and maybe should have less representation than larger neighborhoods, right? Since if we just took a blanket amount, say 5 from each neighborhood, then that wouldn't fully represent this group here that's significantly larger, 4 times as large as this smaller neighborhood here. And so this is a very fair and ethical way to do sampling, and it's called stratified sampling. Again, we have groups, just like cluster, but this time we're only taking a part of each group. So stratified is part of each group. Again, those would be called strata. And this is where we take all of some groups. So we sample all of the individuals, but we only take some of the groups. So this concludes part 2 of our notes on other sampling methods.